Hey guys, I am the math professor Kyle Martin. In this video, we're talking all about inequalities and specifically one-step inequalities. All right, so for each of these problems we're going to do 4 of them. We're going to solve them, graph them, as well as write their interval notation. And then also remember, in the video player down below, there's timestamps. So you can take that little red dot and drag it to whichever part of these you need, whichever question, 1, 2, 3, or 4. Let's get into it. All right, guys, starting with example 1 here, it says x plus 3 is less than 7. And to solve inequalities, it's almost exactly the same as solving equations, all right? So there's gonna be a couple differences we'll get to here in a second. But for this one, if you would think this is an equal sign, right, all we would do to solve this is to move the 3 over by subtracting it. So we're gonna do the exact same thing here. And then those are gonna cancel on the left side, leaving me with just x is less than, and 7 minus 3 is 4. Okay, so we solved it. That's gonna be, remember, part of our, we need 3 parts. We need the solution, we need the graph, and the interval notation. So we're gonna take the solution and put it on the graph. To graph this, I like to use 2 numbers. The number I'm working with, in this case a 4, and then 0. All right, you can use a different number if you want, but 0 is just a good test point. In fact, I have a video where we did this earlier, so if you want to check that out, you can see kind of an intro to these inequalities. All right, but once we have the 0 and 4, we're going to use the 4, and it's going to be less than, which means that I need an open dot at 4. Okay, and then I want all the numbers, all the x's that are less than 0, or that are less than 4. So I'm going to use 0 as my test point. And is 0 less than 4? Yeah, it is. So I'm going to shade towards the 0. Okay, once I've done this, then I need to do my interval notation. And interval notation is just a snapshot of this shading. So we're going to start, like we read a book, left to right. And I start over here at this arrow, which means this goes all the way to negative infinity. Okay, oops, let me do that a little better. All the way to negative infinity. And then it's going until it gets to 4. Going until it gets to 4. Infinities, whether negative or positive, always gets a parentheses around them. And then open dots also get parentheses. If this would have been a closed dot, it would have got a bracket. Since it's open, it gets parentheses. So our 3 parts to our answer are right here. We have our solution, our graph, and our interval notation. All right, example 2 says negative 3y is greater than or equal to 12. Okay, and so for this one, this is one that's slightly different than solving an equation. All right, we're still going to move that 3 over, and by doing that, we have to divide by negative 3. Okay, so they're going to cancel on the left side. That's the same as before. But then, and this is also negative 4, I should say, 12 divided by negative 3. But then, since we're dividing by a negative, whenever you multiply or divide by a negative with inequalities, your sign is going to flip. All right, sign's going to flip. So instead of greater than or equal to, we're actually going to have less than or equal to. Okay, so this is now going to, let's see, we have to use my negative 4 and 0. Negative 4 is on the left side of 0. Since it's a less than or equal to, it's going to be a closed dot at negative 4. Closed dot like this. And then we want all the y values that are less than or equal to negative 4, which means they're these ones. Again, you can use your test point 0. Is 0 less than or equal to negative 4? No, so you're going to shade on the other side. All right, again, we need to write our interval notation, which is a snapshot of this graph, or this shading. Again, starting here at negative infinity, reading it from left to right, goes all the way till negative 4. And again, infinities, positive or negative, always get a parentheses, and then closed dots get a bracket. All right, so again, we have our solution, our graph, and our interval notation for this inequality. All right, number 3 says p over 5 is greater than negative 1. All right, so when we are dividing by something, in order to get that out of our denominator, we need to multiply by that denominator, right? Because then the multiplication and the division will cancel, and that'll go away, leaving me with just the p. All right, so I have to do it on both sides. So here they're going to cancel and give me p is greater than, now even though this is a negative over here, it's what we multiply by. So here I'm multiplying by a positive, so that's not going to change my sign like it did in the other one. Okay, here it's just going to be negative 5. So p is greater than negative 5. To write the graph of this, again, I'm going to use negative 5 and then 0. And let's see, it's a greater than, so it's going to be an open dot, and then greater than negative 5, we're shading this way. Again, a little trick here is as long as your variable is written first, you can shade the way that this arrow is going, whether it's greater than or equal to. Either way, those are both going to be going to the right. Okay, and then the snapshot of our shading for our interval notation, it starts this time at negative 5 and goes all the way to positive infinity. Infinities always get parentheses. Open dots also get parentheses. So these 3 parts are your answer, the solution, the graph, and the interval notation. Okay, last one, number 4 says 6 minus n is greater than or equal to 4. Now, this one's tricky because I kind of snuck in a two-step equation here, and I'll show you why in a second. Doesn't quite look like it, but it actually is. Let's move this 6 over by subtracting it. Currently it's positive. Move it over by subtracting, those are going to cancel. Leave me with a negative n. The most common mistake I'll see students make is they'll leave off this negative. All right, they'll just write n. So that's why this one's kind of tricky. So if you bring down this negative n, now it's negative n is greater than or equal to 4 minus 6 is negative 2. And this is a two-step because the n is not isolated. There's a negative with it. So to undo a negative, this is kind of like a negative 1. Remember, you can divide by negative 1. And those will cancel now. And now we have n. The sign flips. We divided by a negative. So n is less than or equal to positive 2. All right, that's my solution. The graph of this. Again, use 0 and the number you're working with, 2. I like to put a closed dot here because it's going to be less than or equal to. And then is 0 less than or equal to 2? Yeah, so I can shade towards the 0. That's my test point. Shading this way. And then again, the snapshot of that, your interval notation, starting at negative infinity. Oops, that's not very good. Starting at negative infinity and going all the way until 2. The infinities always get parentheses, and then this closed dot is going to have a bracket. All right, so again, our 3 parts here, we have our solution up top, our graph, and our interval notation of this inequality. Hey guys, I hope this video on one-step inequalities helped you out. If it did, I would really appreciate if you'd help me out by subscribing to this channel, okay? There's analytics out there on YouTube that say there's about 98% of you that are not subscribed. So just click that button, please subscribe. It really does help. That said, I wanted to make you aware in the description below is my website, okay? If you, instead of want to search for all these every time, if you wanted to just click a website and then see free organized math videos, you can check out that link below, maybe even bookmark it, right? All those are listed out for you in the description.